Okay, before I model a couple of these Frobenius method solutions for you, a quick analysis of the homework set. What I had to do last night was work on 2 through 13, and all you were supposed to do for them was find the indicial equation and determine which case. Now, when you did that, you should have found the following, which is case 1 was just number 9. Case 2 was numbers 5, 8, and 13. And then all the others were case 3. And all the others include 2, 3, 4, 6, 7, 10, 11, and 12. Now, here's some analysis that's going to kind of help you out in terms of how you want to work on the homework tonight. What I would like you to do is to focus on 4 of these, just because I want you to work on all of the various cases. And I've also selected ones that are a little bit easier to process in terms of working with the series definitions. So the first one that you should do is number 4. It has a few terms in it, and the number of terms, basically the coefficients times each one of the derivatives in y, kind of determine how complex it is. If you have 2 or 3 terms, it's not too bad. When it gets to 4, things get a little crazier. When it's 5 or 6, things get really difficult because each term forms a different infinite series, and the more series you have, the more opportunity there is for interaction between the indices. The next one I want you to work on is 7. Notice those are both case 3s, so they're definitely going to be ones that we'll continue to work on tomorrow. The third one is number 8. It's a case 2. And then the last one, even though it's relatively complex, is the only case 1, which means you can solve it completely. The only downside of number 9 is it's one of the relatively complex ones with 5 terms. Save it for the end. So that basically covers tonight's homework. And any of you who are particularly interested in a challenge, there's something uniquely satisfying about these problems once you can get them to work. There's kind of a thrill about it. I know that sounds major league nerdy, but I think for some of you, you will discover the thrill of working these correctly. And if you're into a challenge, numbers 2, 5, 11, and 13 would be uniquely difficult to find the first solution of just because they include a large number of terms. So if you're into a challenge, maybe try one of these. And unfortunately, some of these problems are challenging enough that not an awful lot of people want to offer solutions for them. So if you check on the homework site, it's pretty sketchy in terms of the solutions that you find for some of these. Some of them are flat out incorrect, and others are on pixelated pictures of sheets of paper that you can't read. So I'm going to try and work out complete solutions to all 4 of these. I'm actually going to work for you as an example in the next video, number 3. But I did just want to give you a little bit of analysis on the homework you're going to work tonight, just so that you can figure out, A, where you're going to spend your time, 4, 7, 8, and 9, the reason why we picked those, and the fact that these are the most approachable problems of the set. So it's a great way to start work on these, all right? And again, if you're interested in a challenge, see if you can do 2, 5, 11, and 13. And remember, keep in mind, all we're doing is the first solution to these. We're only going to do the y1, which is to substitute x to the r1 times the summation n equals 0 to infinity of an x to the n. We're not interested in the second solutions for now, for any of these, other than number 9. Because it's a case 1, you could certainly do both of the solutions to 9 if you were up for it. All right? Okay. In the next video, I'll go ahead and do number 3 for you.